So in this video, we are going to talk through how to graph horizontal and vertical lines. So far, most of the graphs that you've seen have contained two variables, both an x and a y. And the discussion we're going to have today is, can we actually graph equations with only one variable? So things that look like the following. So here we have y equals 5 or x equals 5. Can we graph those? And the answer is yes, and that's what we're going to focus on today. Our first step when we do this, in order to graph these, is you need to get the single variable alone. So when we had both x and y, we always solved for y by itself. If we only have one variable, you're going to start by getting that single variable alone. So here, if we look at 4y equals negative 20, hopefully you're realizing to get the variable by itself, we divide both sides by 4, and we find y equals negative 5. Or over here in the second example, we would start off by adding 2 to undo that negative 2. So we have 3x is equal to 8. And then we divide both sides by 3 to get x equals 8/3. So we're always going to start, if we have just one variable, by getting that single variable by itself. Then, once we have that single variable by itself, it's actually a fairly simple process. We simply need to think through what that equation is telling us about our situation. And if we look here, what I notice is we have y is equal to 4. So what this is saying is that the requirement for every point on this graph, so for every point, y has to equal 4. That is what this equation is telling us. So what we can do is we can go to where y is, and we can say no matter what the point is, y is going to always equal 4. Now, the cool part about this is that there aren't any restrictions on x. They don't tell us anything about x here. It's only y. Y has to be 4. So we can pick anything for x here, because there's no stipulations for it. So we could pick negative 5, 0, 4, and negative 3. It doesn't matter. We can pick whatever values for x we would like. Then from here, we're going to label. So these are all going to be worth 1. So we'll do 1, 2, 3, so we can see that. And then here, we're going to have each of these worth 1 as well. So what we're going to do is we're just going to go, we know that y has to be 4, and we picked whatever values we wanted for x. So we're going to plot each point. X is negative 1, 2, 3, 4, 5, 4. So I can see that point there. I have negative 5, comma 4. Then I have the point 0, comma 4. Then I have the point 4, comma 4. And then I have the point negative 3, comma 4. And hopefully what you're starting to see is when you have all your y values equal to 4 and your x values not having any restrictions, is as you plot all of those points, they begin to form a line horizontally. So we have a horizontal line here where all of the points have a y value equal to 4. Now, for these lines, our domain and range are a little bit different. Here we can see that our graph is going forever to the left and forever to the right. So what this is telling us is that our domain is still all real numbers because we're going forever right and forever left. We're using all of those horizontal number line values. But where this is different is on the range. So the range itself, if we look carefully, what we're going to notice is that the range only has one particular y value. The range are all of our outputs. All of our outputs are equal to 4. Here, the only y value that we're using to make any of these points is y equals 4. So all of our outputs are equal to 4, and as a result, our range is only equal to 4 as well. So let's take a look at a second example here. When I look at this equation, what I notice right off the bat is that this equation only contains one variable of x. And because this equation only contains one variable, we need to start by getting that one variable by itself so that we can then create an accurate graph for it. So we're going to start here by subtracting 5 on each side, so we get 6x is equal to 12. We can then divide each side by 6, so we have x is equal to 2. And now from here, because I have my single variable completely by itself, I can now move forward and create a graph for it. And when I look at this equation, what I notice is that because it only has one variable, I can only really identify information about one variable from this equation. It's telling me that whatever x is for every single coordinate on this particular graph, x is going to be 2. So here I can plot a couple of points where x is going to be 2. Then from here, what it's telling me about y is that y can essentially be anything. Because y is not included in the equation, y can be anything, and so I can pick my y values to have any values. So let's say I do 5, let's say 1, -2, and -3. So now that I have some coordinates, let's go to my coordinate plane and plot them. So I have x is 2, y is 1, 2, 3, 4, 5. So x is 2, y is 5. X is 2, y is 1. X is 2, y is -2. X is 2, y is -3. And what I'm noticing here is that this is forming a vertical line going through all of the points where x is equal to 2. So just by plotting these points from my table, I was able to get a really good idea of where that line is going to be. Now, the final thing I have to do here is find domain and range. What I notice is that this graph is going forever up and down with arrows, and because up and down represents my y values, I know that my range is all real numbers. And then my domain, since I only have one x value here, my domain is talking about my x values, my domain is simply x is equal to 2.